Hello, everyone. We're back. So our next speaker, Seth Green from Metrum Research Group. He's going to speak about MeRGe, an ecosystem of open source R packages for Pharmacometrics from Metrum.
Hello. Thank you for that introduction. I assume you're seeing the screen now. I guess anyone let me know if they're not. This is, I wanted to talk today about an ecosystem of R packages we built for doing pharmacometrics work. And these are all open source packages. And one of the reasons we're starting to share them more now is that we've built what we're calling an expo, which is like an example project in a sense that we've demonstrated through a bunch of vignettes. For people who are used to using R, you know what vignettes are. But if you go to, it's MeRGe. If you just go to this section right here, you will, it'll forward you through metrumrg.com/expo. And what this will show you is sort of a step-by-step through how you could do a simple PopPK analysis. But really the focus of this is not on the science, but on all of the tools that we use to do our work. And these are all tools, for the most part, that we developed at Metrum. And if you go, there's a GitHub repository here that has all of this code. This is set up the way that we would do, as if this was a real project. We have the data and the, plots and figures under deliverables. We have our models in here, all of our R scripts in here, same way we'd organize a project. This about the GitHub repo page will take you through, to how to download that code if you're interested and what's in all these different folders, how to start running through this stuff. And then over on the left, there are introductions to a lot of these packages, and then a project walkthrough where we take you through all the way from the data preparation, exploratory data analysis, the modeling efforts, all the different parts of the modeling, and then how we pull it together with reporting at the end. And today I'm going to give you sort of a whirlwind tour of a few of the packages just to give you a sense of what they do. I'm going to be flipping through these slides quickly because these are designed for a much longer presentation. But I encourage you to check out this website and see all of these tools we built if you're at all interested in this kind of work. Also, for any kind of reproducible research type of stuff, we have a lot of the focus of this is things like we have a whole section on how to, and really gets into it a little bit in this GitHub repo section about how we control the R environment and lock things down so that you can get the exact same versions of packages through the NPN and packager is something that we pull together, and we use it with RENV actually to be able to easily reproduce the same environment that you had when you did your analysis originally. And then a lot of the modeling tools are also about reproducibility, tracking data sets and tracking what changes were made throughout and being able to annotate decisions you made so you can reconstruct your modeling process. And so let me pop you through a few of these slides. These slides are also, I have the Expo booth available at R and Pharma. These slides are on whatever you call rolling through there. So please feel free to check those out anytime if you want to see more about these packages, because again, there's a lot here and we're only going to touch on a little bit of it in the next several minutes. So again, here's the web address where you can check this stuff out, metrumrg.com/expo. I'll put that in the chat when this is done. And then a little bit on the motivation for this, to support traceable, reproducible, and scalable analyses. These are some examples of why you might need some of these tools. You're working on a project with a team, and a lot of these are around being able to create the same plots and figures and do the same kind of analysis consistently, efficiently, but also, each person can produce output that looks the same, plots and figures and things that will all fit together in a report nicely. Another one is being able to easily update people along the way, different stakeholders, whether that's your, your team leader or a client or whatever it is, being able to easily produce sort of intermediate deliverables that show the status of the modeling work. And then these last two are about, I need to come back to my project some years later, whether it's a regulatory submission or we need to pick this project back up and keep working on it. A lot of these tools are designed to make that easy so that you can drop back into your project, see what work was done, and pick up right where you left off. So again, a lot of this begins with this YSpec package. And the idea here is that you provide this data specification document when you submit an analysis to a regulatory agency. And so the YSpec package lets you define a lot of this information up front in a YAML file, and then it pulls that in and lets you check that against your data set to make sure your data set is matching up with your spec before you start your work. It also lets you easily write out this document as a PDF so that you can pass that along. But it also then, the real power comes in when it lets you pull it through and use all that data definition information that you put in to easily label plots and tables and things. And we'll see that very briefly. But this is an example of what the YAML file would look like. You put in a short name and things like decode values for factors. A lot of these data sets will have, for instance, 0 and 1, and that might mean tablet and capsule. If you have your YSpec set up, then when you go to plot this later, that'll automatically get pulled through as the label instead of 0 and 1 without you having to write a lot of, dplyr and ggplot code custom each time. One, that makes it easier, but two, it makes it so that, again, the plots and figures are look consistent between people. I'm going to pass through some of this, but this is sort of what I was mentioning about pulling your data, and you can load your spec and check your spec against your data before you start modeling. Different ways you can explore your data with it. All these, again, have these books, and these are all linked on that website, but you can really start to go through, see in more detail what all these things are doing. For those of you who do non-mem work, we have a package called BBR that we use to interact with non-mem through R. It lets you submit models to non-mem through R. It also lets you copy models and do sort of iterative model development and do some pulling in the non-mem outputs back into R for model evaluation. And then it also lets you annotate your models with tags and notes and things to help you organize them. And this is the submission. Iterative model development, we talked about that. This is all done in R scripts. And so part of the issue with non-mem workflows is a lot of times you're clicking back and forth between different windows and different tools to be modeling in non-mem. We wanted to make it easy enough to stay in R the whole time. Things like pulling your parameter estimates out of the non-mem output files into a simple tibble in R so you can work with them. And then again, adding annotation to your model and then being able to pull that together into a nice, what we call a run log table at the end. And that makes it easier to share. It also makes it easier to come back to your analysis later. These are examples of some of the plotting packages. And so you'll see like the labels here. These are things that get pulled through from YSpec. And so that's another example of why it's great to be able to define your data up front and then use those definitions as you go to pull through. This is just an example of some of the kind of plots that we tend to make in the pharmacometrics analysis, and how all these labels and groups and things get pulled through straight from the YSpec without you having to write much code to do that. I think I'm about up on time. I'll pop through to the end and just say that, well, another thing, we use a lot of parameterized R Markdown for the diagnostics. I'll touch on that real quickly, but there's a whole article on that on the website if you're interested. But basically to be able to pass things through and create these nice HTML reports for looking at diagnostics. And again, it's using all the tools we showed you above to be able to do this without very much code, and rendering them as templates. So here is another plug for the link to check this out. And then if you'd like to look through any of the code, go to about the GitHub repo. It'll walk you through what's in that repo and show you how you can download it and install the packages and start moving along. I think that's all the time I have. Looking in the chat if there are some questions. I guess that I'm not sure which of these, plus 100 for RENV. I totally agree. Great package. Again, you can see on there some of the stuff we do with RENV to help reproducibly create our environments. But thank you very much. Please drop anything in the chat. Mm-hmm.